Good morning, students. The next problem in the CET part is question number 82. A hollow sphere of radius 5 centimeters, and whether it is hollow or solid, no. The final formula's result is same. Inside surface 5 centimeters is charged such that potential on the surface is 10 volts. Find the potential at the center. Here in this case, for any sphere, even include solid also, V inside will be always equal to V surface. Surface, whatever potential is there, same potential is present at the center also, everywhere also inside only. And if R is a distance taken from center to any point, if R is a distance from center, if R is less than or equal to capital R, then V inside will be equal to V surface. You are asked is at center. At center means that is automatically inside only. So at center also potentially same as the surface. Surface 10 volts means every case 10 volts inside. Surface inside center also 10 volts only. That is the answer. If R is equal to after surface is same, what is the V surface? V surface is nothing but equal to given after 10 volts is equals to Q by 4 pi from the capital R. But if it is outside only, the formula will be different. V outside, if it is taken, that is nothing but equal to Q by 4 pi epsilon into the distance square. Outside means R is greater than capital into R with relationship. And V surface is equals to Q by 4 pi epsilon into capital. Here smaller capital, that is the difference. Up to surface, in case if they give you charge and radius, we have to use this relation. Directly value is given, same value to mention. Everywhere is up to the center also. Next problem is 83. This is very important problem. This 83 is a basic concept question of the lecture, critical question, and generally asked for 1 mark question in theory also. Infinite series. A hollow sphere, an infinite number of charges of equal magnitude, q coulombs, an infinite number of charges of equal magnitude q coulombs, but alternatively opposite sign. Sign are placed on the x-axis or on the x-axis. They are placed on the x-axis. X-axis at x equal to 1, x equal to 2, x equal to 4, and so on. Find electric potential at the point x equal to 0. Point electric potential at the point x equal to 0 means at origin points with these charges. You are not given the distance as centimeters, meters, no, just units terms will take whatever units I mentioned. So, formula we need to take. This is origin, x axis, y axis, and charges, all identical charges. Okay. This is Q, 1 meter. This is going to next is 2 meters. And next is 4 meters, and so on. This is R1, this is R2, this is R3, and so on. We want the potentials. Previously, we are taking a similar problem for the electric field. Electric field potential difference is potential inversely proportional to distance R, electric inversely proportional to R square terms. So that you have to be careful. Answer: each charge is Q. distances are x1 quantity required. So potential, total potential H. But alternately given, alternately 1 minute careful with that, alternately opposite charges means what? One is plus q, means another one is minus q. Plus q, minus q. You have to be careful with that. So underline that in the question answer. So each charge is, magnitude is q, and they are actually plus q, minus q, plus q, minus q. Delta gas, plus q, minus q, plus q, and so on. Potential at, total potential at origin x equal to 0 is V total at equal to 1 by 4/5 epsilon naught, and this is V1 V2, V1 plus V2 plus and so on. Any number will take up to infinity, which is equals to 1 by 4/5 epsilon anyway common. Not medium not mentioned means don't take the k. Take it as a error by k equal to q1 by r1 or x1. We'll take this as k2 by r2 plus and so on, which is options are given in terms of symbols only. So don't take 90 to the power of 9. 4/5 epsilon naught into q1 is plus q, second one is minus q. This is q by r1 is 1. This is x1, x2, x3 on the meter, I think. This is I will write as a x1 distances, x2, this is q3 by x3. So first is the positive charge I am taking, q by 1. Next we will get is minus q by, the distance is 2. In the electric, 1 square, 2 square comes in the denominator. Next is again positive, q by 4 it is. Next is minus q by, whatever the distance comes, no, 2, 4, 8, like that you will get a, just u, and so on. We require just 2 separate terms. This is summation to infinity. Q also take out common. So you take out the common q by 4/5 epsilon naught into 1 minus half plus 1 by 4 minus and so on. So this term summation to infinity. For summation to infinity is S infinity equal to a by 1 minus r. A is the first term, so this is going to be a. This is a. And common ratio is smaller equal to second term by first term. 1 by 4 by minus 1 by 2. So negative term becomes. So this VO is equals to q by 4/5 epsilon naught into summation to infinity. Summation to infinity is a by 1 minus r. A is 1 by 1 minus r is 1 by 4 by minus 1 by 2, which becomes equal to, mention separately, a is 1, r is equals to 1 by 4 by minus 1 by 2, which is 1 by 4 into 2 by 1, which is minus 1 by 2. So summation to infinity becomes equal to, is equals to q by 4/5 epsilon naught into a is 1, 1 by 1 minus half, 1 minus half becomes equal to plus. Sorry, S infinity becomes equal to 1 by 1 minus of, which is equals to, this becomes equal to 3. 1 plus half, 1 by 3 by 3 becomes equal to 2 by 3. So the result, this becomes equal to summation to infinity equal to S infinity is 2 by 3. This is nothing but equal to 2 by 3. So 4 2s are, you don't need to complete. 2 2s are 4. The result becomes is q by 6 by epsilon. That is the answer. We not accept this one, but equal to this answer. So you must reduce the steps. No need to take all the steps directly. Okay. You must be able to find out this step directly. Common terms charges take out, but plus minus only value substitution directly out here. From here only you must be able to take up the steps. Not all the steps are required. Okay. Theory exams till now they didn't ask you infinite series, but if they ask also you must be able to work out all the steps there. But competitive exams directly start from here. Next 86. I'm sorry, not 86. It is 84. Three charges. This is important one. Star is there. These problems with the star are very important. Three charges. Minus Q, Q, and minus Q are at equal distance on a straight line, are placed at equal distance on straight line. If the total potential energy of the system is 0, potential energy of the system is 0, then Q by Q, then find the ratio capital Q small equal to h. What is the manipulation? I have to find out Q is to K is how much. All charges are in the straight line. It is not like a triangle or something. And total potential energy is 0. Mutual potential energy means. So they are all on the same line. Let us take for simplicity the x-axis. I will take minus Q. Yes. Q, and Q. This is minus Q, Q. Not necessarily the size should be bigger or smaller, does not matter. Size only indicates size of the particles. Like electron is small, proton is bigger itself, very much bigger, but charge is equal. So size does not indicate the value of it here, just approximately the value. Because value is not mentioned. They are equal distance therefore. For example, this distance is A, or else I will take this distance is R1, this distance is R2, and this distance is R, this is Q1, Q2, Q3. So I will take this as R12, this is R23, and the total sub distance from here to here is R1. Not compulsory, symbols your choice. So mutual potential energy you have to find out. To do a mutual potential energy formula for two charges is what U12 equal to Q1 Q2 by 4 pi epsilon into R12. Okay, denominator comes only distances. Numerator comes multiplication of the charges. Formula for the force you know, Coulomb force. Into distance becomes equal to potential energy by multiplication. So denominator one distance square is R square, R cancels. So we'll take mutual potential energy. Answer. Total mutual potential energy. Total mutual potential energy. What is mutual potential energy? Total energy worked done to bring these three charges from infinity to form this system. It's finite separation. That is called as the mutual potential energy. Is U total equal to U12 plus U23. U12 plus U23 plus U13. Interaction between these two forces, how many are that you have to take. But these two are distances they are given. This is nothing but equal to, I will take it as A. This also I will take it as A. So this becomes equal to how much is 2A. Or if you take R, this becomes equal to R. That like that you have to make it. Next, this part. U12 is Q1, Q2, and write with the symbols, write out substitution. Okay, but directly you must work out with the last step. Q1, Q2 by 4 pi epsilon naught into R1 plus U23, Q2, Q3 by 4 pi epsilon naught into R23 plus Q1, Q3 by 4 pi epsilon naught into R23. Q1, Q2 is minus Q, and what is given in the question? The resultant potential energy is 0. Total potential energy is 0 therefore. So this equal to 0. This equal to 0. So this term becomes equal to Q1 Q2 is minus Q into Q by 4 pi epsilon naught into R12 is A aerotic plus Q2 Q3. Q2 is capital Q and Q3 means minus it becomes minus QQ again by 4 pi epsilon naught into R23 is also A plus minus into minus becomes equal to plus Q into Q is Q square by 4 pi epsilon naught into 2A equal to 0. In this you take out common terms. What you can take out common is Q by 4 pi epsilon naught A you can take out common. Okay, and that whatever you take out common, if you take it to the right side, it 0 into something constant. Okay, that becomes equal to 0. So common terms you can cancel it when the equation right side is 0. So what I can take out common in this expression is, first I will take the step of the common terms, capital Q, one small q and capital, I will take it as a minus terms. Minus as it as I am putting, so Q I will take by 4 pi epsilon naught into A I will take out common. In the first term that becomes equal to only minus Q remains. Second terms is also minus Q remains. So we can take this as a 2 times also. And here we will get a small Q remains. By denominator A I have taken common or 2 will be there. Q by 2 equal to 0. So this constant term taken to the right side becomes equal to 0. Therefore this becomes equal to minus 2Q plus Q by 2 equal to 0. Minus 2Q taken to the right side becomes equal to plus. So next step is minus 2Q plus Q by 2 equal to 0 and Q by 2 or 2Q equal to Q by 2. If we want ratio, capital Q by small q, sometimes they will ask you small q by capital Q also. So we want Q by Q is equals to Q by 4 or Q by Q ratio is 1 by 1 is to 4 is the answer supposed to be. So in this lecture we must be able to work out without using these symbols. Total potential energy, this is U total. From here we need to work out equal to 0. So common terms whatever is there, no, you don't have to write also. 1 by 4 plus not common everywhere. You don't have to write. Remaining part of the next problem you can easily work out 81, similar problem of total potentials. Also you can work out. Next is 88 will work out. 88. A charged spherical conductor has a surface charge density 0.7 coulomb per square meter. Spherical conductor has surface charge density surface charge density of 0.7 coulomb per square meter. Charge is increased by 0.44 coulombs. Charge is increased by 0.44 coulombs. I write as if charge is increased by 0.44 coulomb, the surface charge changes by, then surface charge density changes by 0.14 coulomb per square meters. Find radius of the sphere. Find radius of the sphere. One sphere is there having the charge on the surface. Radius is r. And surface charge density is sigma here. Charge is q on the surface. Sigma is equals to q by a formula. A is nothing but equal to area is 4 pi r square. So basic formula for the surface charge density. Answer. Surface charge density basic formula is sigma is equals to q by a. Area of the sphere is q by 4 pi r square. Area A equal to 4 pi r square. But here what change is charge is changing. Be careful with the term. What is the term change is increased by, not increased to. Question you have to be careful. Increased to means final value, single value. Increased by means change you are taking, difference you are taking. Final minus the initial difference you are taking. So charge density changes by here also. By means also changes. That means what we are taking the first one sigma 1. Second time we are taking it as a sigma 2. Sigma 1 is nothing but equal to q1. Sigma 2 if you take no, q2 you will get. Write this separately. q1 by a do not change. So we take as sigma 1 is q1 by 4 pi r square. And sigma 2 is q2 by 4 pi r square. Change is delta sigma is sigma 2 minus sigma 1. Difference is it can be increased or decreased, does not matter. E is nothing but equal to 1 by 4 pi q2 minus q1. Difference is 1 cancel comes is 4 pi r square as it is. Nothing but equal to q2 minus q1 by 4 pi r square solution. So you have to be careful with this. You don't have to remember this all. You don't have to take all this lecture. Just remember delta sigma is equals to delta q by 4 pi r square. This relation you have to change values. Basic formula if you know changes are there means delta sigma value directly given. Delta q value also directly given. This is a constant not changing. So as it is equal. So this one you have to take directly. Delta sigma is given for you. Charge is increased is this much coulombs. Coulomb per square meter is sigma relation. This is nothing but equal to delta sigma. This is nothing but equal to what is delta q relation. So given is given delta sigma changing surface charge density 0.14 coulomb per square meters and delta q is 0.4 kelvins. Therefore, you can get delta sigma r square. We can substitute the later on. Delta sigma is 0.14 is equals to delta q is 0.44 by 4 into 20 pi. We get with this pi, don't take 3.14 for calculation purposes. Okay, you will be given the calculation such that easily you can divide it. So 22 by 7 you better take, we can easily divide this. So we get this as 22 by 7 you have to take into r square. Decimals directly can cancel, left and right side, and r square you have to take. Therefore r square is equals to 0.44 by 0.14 into 1 by 4 into 22. 7 go to the numerator. And 4 by this value r square came here. 4 as it is, 22 as it is, 7 go to the numerator. So what get decimal I can cancel here. Okay, this 22 2s are 44. 7 2s are 14. 2 cancels. Left out is 1 by 4. It is r square. This is 1 by 4. R is equals to 1 by root 4, which is 1 by 2, which is 0. R in SI units. So this is supposed to be meters. So you must take only from here units. Substitution here. 89 also important ones. I didn't put the star for that, but you have to put the star. That is very important ones. Next is 89. Electric field in the region of space is electric fields. Electric fields is E is equals to 5I plus 2J. 5I plus 2J. Newton per coulomb or volt per meter. And electric flux due to this field through area, find electric flux through the area of 2 meters square, through the area 2 meters square. And where is that area lying? Or imaginary plane? In XY plane. Lying in, so not XY, is YZ plane. Or in SI units you take. In SI units, so you need to take. Electric flux is nothing but equal to E dot K. Here we are given the electric field in vector form I have mentioned, ij case, equal to 5I plus 2j. And the coordinates, how do you have these coordinates? So this is x, y, z. And whatever the surface plane is given, that is area is 2 meters square, but it is lying in yz plane, this is a plane. So I take a plane is like this. It is nothing but a yz plane. This is the area. What is the area vector? Area vector is perpendicular to area. The z-axis is not like this actually. Z-axis actually is like this. This is z-axis, x, y, z. So yz plane is like this. So area is here. So what is normal to the area? We didn't mention the direction. But it's our choice means take the positive direction. This is the direction of area vector. So this is the direction of n cap or area vector we have to take. So that means what is the unit vector in the direction is I, j. This is a. So area vector. Area vector is how much? 2 meters square. 2 meters square into units. So that component along y-axis meters square. This is along x-axis. Electric flux. Phi equal to E dot A.